9701, Winter 16, Paper 11, Question 1, Discussion. The diagram represents, for a given temperature, the Boltzmann distribution of the kinetic energies of the molecules in a mixture of two gases that react together. The activation energy for the reaction EA is marked over here. So y-axis represents proportion of molecules with a given energy. X-axis is represented by molecular energy. The dotted curves below show the Boltzmann distribution for the same reaction at a higher temperature. On these diagrams, H represents the activation energy at the higher temperature. Which diagram is correct? Let's look at A. So H down here is supposed to represent the activation at the higher temperature. And in these graphs, you have a curve which is dotted to indicate possibly the Boltzmann distribution at a higher temperature for the same reaction. Now let's take a look at the question again. The diagram represents, for a given temperature, the Boltzmann distribution of the kinetic energies of the molecules in a mixture of two gases that react together. The activation energy for the reaction EA is marked here below. You can see it. Now the dotted curves in the diagram of the answers show the Boltzmann distribution for the same reaction at a higher temperature. So higher temperature is a key word here. So we have to identify the diagram that correctly describes the Boltzmann distribution of the kinetic energies of the molecules at a higher temperature. Here's an arrow. Now, the peak shifts to the right because more particles have higher kinetic energy. At a higher temperature, particles move faster, therefore they have higher kinetic energy. Or we can say that the peak shifts to the right because the average kinetic energy of the molecules is higher. Next point, the peak will drop in height. This is because the area under the curve, so all this area under the curve represents the total number of particles. Since the total number of particles is a constant, the peak will drop in height. So we'll expect the curve to look like this. Yes, it should start from the origin. It should be 0, 0 origin. So it will look like the brown curve. Now, since more particles have kinetic energy greater than the activation energy, the brown curve intersects the EA, activation energy, axis at a higher point. A low temperature is down here, the higher temperature is up here. Note, activation energy does not change at all with temperature. So H should be down the same as EA here. So let's look at the diagrams. A, B, C, D. Which one is the correct diagram? With A, the peak is higher, although the peak is shifted to the right. Activation energy, same at high and low temperature. For answer B, peak has shifted to the right and peak has dropped, which is correct as expected, but the activation energy for higher temperature is less than the activation energy at low temperature. And we can look at C as well. Here the peak is shifted to the right and has come down. Activation energy, same at high or low temperature. Could this be the answer? Let's check D. In case of D, the peak has shifted to the left and has come down in state. Although the activation energy E is the same at low and at high. Well, the best thing to do is look again at what we expected. Shift to the right, a drop of the peak. H should be the same as EA. Look again. Now we match up. Is it A? Is it B? Is it C? Is it D? Can only be C. Yes, C is the correct answer. Thank you for watching. Make sure you subscribe to Campow to support future developments.